So I assume all of us are good until the key binding setup. So the first thing that we're going to look into is atomic types in Clojure. So these are the things which already Tamara has shown us during the slides, its slide presentation. So now we'll be just evaluating it and seeing it for ourselves. So the first thing is long. So typically any integers. So the underlying Clojure implementation. So the underlying Java object for the numbers is either long or java.lang.long. So it will be either a primitive or object. So based on the context. So to evaluate it, you have to press Alt slash. Sorry, before that you have to start the REPL. So you have a button named End REPL at the bottom. You have to click on that, and you have to click on Start a REPL server and connect. So you have to wait for this message Jack and done. So once that is done, you'll be able to evaluate your Clojure code with REPL. So based on what are the key binding that we have already done, if you click Alt slash, whatever the current form on which you have placed the cursor, it will get evaluated. So so you'll see. So current form in the sense it can either be whatever the symbol or primitives or data structures or any Clojure expression, whatever valid Clojure form it may be. So I'm just sending one to REPL and it just returns one. So one is getting evaluated to itself. And the next thing is a character. So you'll have a slash followed by what are the character that you have to specify. So I'm just sending a character to REPL and it's getting evaluated to itself. And so the underlying implementation will be either a char or character class based on the context. So my examples are more in the perspective of Java, since that's what we played around with a lot. But for JavaScript, there'll be equivalent implementation which takes care of the representations. But the syntax stays the same even for Clojure script. So for string, when you just send a string to the REPL, it gets evaluated to itself. So what we are seeing now is we are just getting comfortable with what are the primitives that we have. So we are not getting into any expressions or syntax per se as of now. And the next thing is a regular expression. So once you have your string prepended with a hash, that will be considered as a regular expression. So you don't have to create any special class or anything for regular expression, unlike in most other languages. And the next thing is keyword. So for the moment, you can consider keyword is something like a string, but it has additional advantages which we will see in future sessions. So one such thing is keywords will have namespaces similar to the one which Tamar was showing in his API demo. So we'll dig deeper into the keywords in the future session. And the next thing is ratio. So any improper fraction that you have will be evaluated to a ratio. So the value will not be divided, and you won't see any float values. So this is to avoid any rounding off that could happen in which you might lose precision. So if you have to do the division, if you want the division to happen, and if you want to have the return value in decimals, you have to do it explicitly, which we'll see in later session. And booleans, so which is true and false. And the next thing is nil, which is equivalent to null in Java, JavaScript, and none in Python. So for the moment, these are some of the basic primitives that we have. There are a bit more, so which we will cover as and when it's needed. And as you're seeing, you might have a feel like whatever we are doing here, you might get a feel like Clojure is an interpreted language, but that's not the case. Clojure is basically a compiled language. So what are the expressions that we are evaluating? It's dynamically compiled into Java classes, and it's being evaluated. And so behind the scenes, it's using ASM library for the moment. So probably you can take a moment to evaluate all these things by yourself, and see if you're getting the results. If you're stuck anywhere, just feel free to ping us. Probably I'll stop for a minute before I move on to the next session or next topic. So I hope we are good until this point. If not, please feel free to stop us or ping us.
Kanan?
SG.
Yeah, the regex one, like anything starts with has considered as a, I mean, sharp considered as a regex or how
Yeah,
it
that's
is?
right.
Okay.
So hash and followed by a string, that's considered as a regex.
Okay.
So yeah, okay. Let me move on. Feel free to stop us if you have any questions. Feel free to ping or just unmute yourself and speak out if needed. So these are things which Tamar has mostly covered as part of his presentation, but we'll just evaluate it ourselves to get a feel of it. So the first thing is vector. So you'll have the elements and which is enclosed within square brackets. So since Clojure is a dynamically typed language, you can put any heterogeneous types within the vector and create an vector that applies for any data structure for that matter. So this is essentially like an array or array list or list, and there's a data structure called list, so which is also a sequential data structure. So this is essentially a linked list. So so typically we will use vector, and there are certain cases in which we'll use list. So we'll come there when it's time to explore more on those. But basically, both are sequential data structures. And the next thing is set. So basically, a set allows only unique elements, but it won't allow duplicates, and the order within a set is not guaranteed to be maintained. For example, if you see, I have created a set using 1, 2, 3, and 4 string, and I have sent this whole thing to REPL, and whatever I got back from closure REPL is 1, 3, 2, and 4. So whatever the order that I have sent to the REPL is not maintained when the set is created. So the purpose of set is not to guarantee the order of the element, but it guarantees the uniqueness of the element. So if I try creating a set with duplicate elements, so I will fail. And you'll see the message at the bottom, duplicate key 3. And the next thing is map. So it's like a indexed elements. So I'm just creating a map with key as keyword 1 and value as 1, and key as keyword 2 and value as 2, and key as keyword 3 and value as 3. So it's if keyword is confusing for you, you can even create it with a string. It works the same way. So all the typical collections that Clojure has are immutable, and by what I mean immutability is probably if you are from functional background, you might be aware. So you'll not be able to change whatever the collection that you have created. You'll have to work around with uh, a recursion and out of box operators like map, reduce, and filter, things like that too. Probably will come there when it's time. Yeah, but as a fact, it's good to know that all the collections are immutable. So probably we can take a couple of minutes to create your own vector and your own list and your own set and your own map. Please feel free to ping us if you're not getting anything, or feel free to unmute and speak to us if you're not clear on any of these things. And you can just start creating your vector list, set, and map. So the next thing we'll start doing some operation on what are the data structures that we have seen. Okay. So Tamas already explained the S expression, but I'll just recap. So when it comes to closure expression, you'll have parentheses, and the first literal after the parenthesis will be an operator. So closure will try to evaluate whatever the first element that comes after the parenthesis, and followed by whatever the arguments that you will supply to the operator that you gave first. So if you have to add two numbers, you will say plus and what are the numbers that you have to add, and enclosed within parentheses. So as you might have seen the earlier slides, this can be extended to any number of numbers. So that's with respect to adding, and we can also have similarly we have multiply, and with respect to equality checks, you have equal to operator. So unlike we have seen in other languages or other notation, So you'll be able to do equality check on multiple values at once. For example, if you're checking if 1 is equal to 1 is equal to 1, and you'll get true. And if you're for this particular expression, you'll get false because 1 is not is equal to 2, and which is not equal to 3. So basically, most of the operators that you have can be extended to any number of arguments. And one of the most confusing operator in this particular notation is greater than and less than. So it'll make more sense if you change the perception in which you see the operator. So when you see this particular operator, so typically what we'll think of this one is, we'll think this one as a greater than operator, and we tend to think if this operator checks whatever the number is pointing towards, it's near to the nose is smaller or not. That's what we typically tend to think. But actually, this operator is like it's a descending operator. So what it checks is whatever the sequence of numbers that comes after the operator is in descending order or not. So probably you can instead of seeing the nose, you can see the uh, descending slope of the operator. So basically, that's what it does. So here we are checking what are the series followed by this operator is in descending order. So obviously 4, 3 is in descending order. So you'll get true. And 4, 3, 2 is in descending order. So you'll get true. And we can extend it for any number of numbers. And 4, 3, 4 is not in descending order. So you'll get false. So similarly, you'll have ascending operator. So it will check what are the number follows the operator is in ascending order or increasing order. So obviously 1, 2, 3 are in ascending order, so you get true. And 1, 4, 2, 3 is not in ascending order, and you get false. And even if you put 1, 2, 2, it's not in ascending order, so you'll get false. So if you have to check, if you have to allow equals as well, that is you can use ascending or equal to. So once you see the operator in the perception that I mentioned, it will be easy for you to get a grasp of it. And we have logical operators, and or so it's typically a short circuit similar to any other language that we see. So basically, it will return a first a non-false value, or sorry, with respect to, or it returns the first non-false value. With respect to and, it will evaluate all the arguments that it has, and it returns. If everything is true, then it returns true. And we have a negation. And what are the operators that I have mentioned, and what are the operators that you'll be seeing? It can be nested, as you might have seen the earlier slides. We'll get our hands on in nested operators soon. And the next thing is conditionals. So for if else, the syntax is you have if operator and followed by a condition. So based on what are the value that's being returned by the condition, if the value is a true equivalent, then the total value returned by this whole expression will be from the true branch. And if this is evaluated to false, whatever that in the false branch will be evaluated, and that value is returned. So here, what are the expressions that I have put? It checks if the expression, this particular expression evaluates to true. So basically, it's a descending expression. It checks if 3, 1 is in descending order. If it's true, then 3 will be written. If it's false, then 1 will be written. So obviously, this is true. So 3 will be written as part of my total expression. So this is an example for another nested expression. So I have an expression plus 1, 1, and I'm checking if it's equal to 2. So obviously, it's equal to true. So far good. And do you want me to reiterate anything? Can you try evaluating this expression for yourself once? Then we'll move on to the next section. Probably you can take a minute. What's the error that you're getting, Sundar? Okay, so if you're getting that error, so probably what you can do is you can move the cursor to the top, and you'll have an expression ns, right? So you can try evaluating that.
Maybe sometimes it's disconnects from the REBL server. We have to restart
the
it.
server, is it?
Yes.
Okay.
I have restarted 2-3 times. Maybe because of internet. Not sure.
So if I select the whole,
No, you don't have to select the whole. You can just keep your cursor at the end of either end of parenthesis or start of parenthesis, and once you evaluate that thing,
that doesn't work actually. So if I select the whole program and then execute, then it works. Otherwise, it doesn't work. I don't know why.
No, are you able to execute that ns expression alone?
Alone.
So you can just place your cursor at the end, and you can.
Yes. Yeah, it works.
Then.
Yeah. After that, it works. Yeah, this one works.
Cool. Yeah. Okay. Let's just move on to the next problem. So the next thing is create a no already function which prints a message. So you can refer to the functions.clj to see the syntax for a function creation. So you have to create a function with any name that you want, which doesn't accept any parameter, and it has to print a message. So probably we can take a minute. So once you're done, you can ping a solution to the chat. Okay, so probably what I'll do is I'll also type the solution as soon as I'm done with a particular thing, and we'll move on to the next problem together. So I assume you would have tried second one. Can we move on to the third one? So the next problem is create a function that squares a given number. So you have to write a function which accepts a parameter and it multiplies the number by itself. Yeah, happy to see the responses. Cool. Cool. I'm just writing the solution. So I'm creating a function named sq and which accepts one argument and it returns the square. So I can say sq5, the value will be 25. So Vic, one minor change with the solution that you gave is it prints the square, but you don't get what's the value of the square. So as you have seen earlier.
Yeah, okay, got it, Kannan. Yes.
Yeah. So typically the last expression will is expected to be the value that your function has to return. Okay. So the next problem is you have to create a function which checks if a given number is in the range of 1 to 10 inclusive. So you have to write a function, a singularity function, and it will check if the given number is within the range of 1 to 10. So inclusive, 1 and 10 are inclusive. So you can either use ascending or descending operator, and ascending equal to and descending equal to operator. So we'll take a minute, then I'll give the solution. So probably we'll go over 4 and 5. We'll skip 6 for the moment in the interest of time. So probably you can take that as one of the assignments that we are going to give. So yeah, okay, bro, no issues. So I think a couple of people had to drop off or be on hold from the meeting because it's going over the time.
Kannan?
Is it?
And do we need to compile kind of thing before like calling the function? Like I have written the function.
Yeah.
When I am trying to call. Okay, then
first we have to evaluate this. For example,
yeah, okay,
if I have this function definition, I have to yeah.
Okay, I tried
So basically,
3 times. Okay.
Oh, okay.
Like after evaluating, I just tried calling again the next line, so it was evaluating correctly.
Okay.
Yeah.
So let me move on to the solution. So I'm just going to create a function which checks if a given number is in the range of 1 to 10. So you can even use question mark as part of your function names. So that tells if that particular function is checking for a condition and returns true or false. That's one of the typical way that we use in Clojure. And it accepts an argument and it checks if a given number is in the range of 1 to 10. So for that, I'm going to use designing equals operator. So the first argument will be 10 and second argument will be whatever the number that we are going to check, and third argument will be 1. I'm checking if 1 is in range of 1 to 10, it says true. And I'm checking if 10 is in the range of 1 to 10, it returns true. And I'm checking if 2 is in range of 1 to 10, it returns true. And I'm checking if 11 is in range of 1 to 10, it returns false. So basically, it does whatever we are expecting it to do. So if you have to try a different flavor, you can use instead of design equals, you can use as an equals, and you'll be required to invert the order of numbers that you put here. Or if you're going without equals, if you're going to try means, you have to put 0 and 11. So those are the different flavors that you can try. And the next thing is you have to create a function which accepts two numbers, and it has to find the average of two numbers. So you'll be required to try a nested S expression here. So if you're wondering what S expression means, uh, whatever, so this particular syntax in which operator followed by operands enclosed within parentheses, that particular syntax is called S expression. And Sindhil tried a different solution. That's also good. Yeah, but when you use this operator effectively, it will be more concise. So whatever the solution that Sindhil gave is more in the sense of a typical conventional greater than less than operator, which accepts only two parameters. So you have to, if you have to compare three numbers, you have to do at least two checks to ensure it. But with respect to Clojure, you can compare more than two numbers at once. So with which you will be get it done with only one conditional check. So that's one of the mental shift that you'll get once you're accustomed to these operator, and those are one of the reasons which will make your Clojure program much concise. So I have tried with an experiment on the source of Clojure conciseness. So I was trying to write a program called Convoy Game Open in Java, and I also saw another solution in Clojure. So the best that I can get out of Java version is 90 lines of code, and the same logic someone has written in Clojure in just 7 lines of code. That's how concise Clojure will be. So you'll be able to get those things if you're leveraging the operators and function in a way it's meant to be. Okay, I think it's more than a minute. I have done a lot of talking, but let's move on to the solution in the interest of everyone's time. So I'm going to create a function which averages two numbers. So adding two numbers. So it'll be much expressive if we use a thread macros. So since we haven't gone through it formally, I'm not using threading macros, and I'm just using it in a typical nested expression way. So what I'm doing is I'm just adding A and B first, then I'm pausing the value of the sum and dividing it by 2. So fine. It will give you 15 by 2 because it will return the ratio whenever it cannot be evaluated to a proper integer. So in which case we can use a float operator. So now you can see the value transfer to a float number. So that's it with respect to the practice based on whatever we have seen so far. So I want to namespace and var. Tamar, would you like to take over this particular part?
Yeah, you can take Kannan. I'm fine.
Sorry?
You can take that by yourself, Kannan. I'm fine with that.
Okay, okay, fine. No, I thought probably you can add more information to this particular point. If you're comfortable. Okay, fine. Let's continue. So the next part I would like to cover is namespace and vars. So namespace can be considered as collections in Java, and I think with React and things like that. I'm not sure about the exact term in React, but you have some terms which represents a total namespace, or it helps you to group variables or files typically. So that's the purpose of namespace. It lets you groups variables and files under a particular name. So typically the namespace will be like you'll have typically whatever the folder name and whatever the file in which the program so whatever namespace that I have used here is strong. So it has to reflect the name of the file here. So we have done some refactoring and we didn't take anything. So focusing on the snippets that we're writing. So take a namespace is for grouping, and vars is for so typically you don't create variables like you create in other imperative style of programming like Java, JavaScript. So mostly you'll be working with recursions, and you'll be working with map, filter, and reduce, which doesn't need any explicit intermediate variables. So, but if at all you need to use any intermediate variables, you'll use let expressions. So basically, what let does you value of your expression intermediately, and you'll use that particular variable within our scope. For example, here I have a let variable, and syntax of let is like you'll have a vector which has to have even number of arguments, in which the first one will be the variable name, followed by the expression which will be evaluated and the value will be assigned to the sum. So what I'm doing is I'm just summing 3 numbers and assigning to temporary variable sum, and I'm just printing it. So you can see the result. So if I try to evaluate sum here, you will get syntax error because sum is only within the scope of length. So you can use this intermediate variable within the scope of length. For example, I can find an average thing. So whatever the variable that I have just evaluated, I can just use it to create one more variable average. So which says divide sum by 3 and store it in average, and I'm just printing average. Okay, so the confusion is because I used print. So as you can see, this prints 6 and this prints 2. That's what you are seeing as 62 in the earlier prints. So I was just confused what 62 means here. And there are additional variable types such as var, atom, and refs. So which will be mostly useful in cases of multi-threading, and there are concepts like software transaction management, which helps you to efficiently operate in multi-thread environments. So basically, we'll come there when we'll be when it's time to see. So those are bit advanced concepts. We'll come there eventually. And we'll go through typical operations. SG. Hello. Yes, Shankar. Were you about to say something, Shankar? Okay. So we'll just quickly go through a couple of operations over collections and some additional operations over collections. Then we'll have a end note and assignments. So it will be in max of 20 minutes. So is that fine for everyone?
Yeah.
Shankar, Sandil,
Yeah, fine for me.
Gopinath. Okay. Okay. So with respect to collections, so so the first operator is n. So if you have to get n element of a particular collection, we'll use n. So to get element at index 1, you do scan, and what are the collection you have to get element from, and what are the index from which you have to get element from. So this is typically applicable for vector and list. So that's where it makes more sense, because those are the two collections which retains the order. And to add element to a collection, use conj. So as you are seeing here, I'm having and I'm appending file to it, so it can be visible. So with respect to list, the conj will add the element to the front. So basically, based on these properties, you will choose the appropriate collection. So with respect to, as I mentioned earlier, list is basically a linked list, and vector is basically uh, like an array in which the elements are sequential, and random access is quick. Whereas in case of list, addition is quick. Whereas to access, you have to go through the total chain of the linked list. So that's what I mentioned here. So for list, adding elements will be faster, and reading will be relatively slow compared to the vector. And for vector, reading will be fast, and adding will be relatively slow. So I'll just try to explain what immutability means. So whatever I'm doing is not exactly an idiomatic way of doing closure, but that solves the purpose of explaining immutability. So assume that I'm just creating, defining a variable with vector 1, 2, 3, 4, and I'm just dropping second element from the vector. Sorry, dropping first two elements from the vector. So I think drop the first argument is until you have to drop, and after that it will return the remaining elements. So I'm just dropping the first two elements, and it returns 3 and 4. So so basically, how many ever times you evaluate the same expression, the result will be the same. It will be 3 and 4. So the reason being, whatever the drop operation that I'm doing won't affect whatever the data structure that I'm operating on. So whatever the operation I'm doing will be applied on top of the data structure, and the new data structure will be returned. So any operation that you do, like conj or anything that seems to be changing the actual data structure, doesn't actually touch the value of the data structure. It just takes the value, do whatever operation it wants, and it returns a new data structure. So for example, if you're doing a similar thing for conj, so how many ever times you do it, it will just append to the existing data structure, and it will create a. So you might be thinking that instead of affecting this A vector, if you have to create a new one, so you have to take all these things and put 2 to it, and you have to return a new one. It might be an inefficient way of manipulating the data structure. Actually, it's not an efficient way. So there is a concept called persistent data structure. So it's similar to the concept of that's being used in virtual tracking systems like Git. So it gives you capacity to do any changes on top of the existing system without touching what are the changes on a particular commit. So it doesn't mean for each commit ID you're creating a copy of the total file by yourself. So basically, you'll be just capturing what are the changes for each commits, in such a way that you'll be able to recreate the total any file at a particular commit ID. So that's an efficient way of change without actually mutating a particular variable or particular commit. So the underlying logic is the same. So probably you can read more about persistent data structures. So I'll just like to cover a couple of operators on collections. So the one is map and other one is reduce. So if you say map, so what map does is it takes a function and it takes a collection. So it iterates through each element in the collection and it applies a given function on each of those elements, and it has another collection with the return value from the applied function. For example, when I execute the expression, so this is how it goes. So you have 4 elements in the collection, 1, 2, 3, and 4. Okay, so I'll just rename it to. So you have 4 elements, 1, 2, 3, and 4, and on each of those elements, the operator that I have put here will be applied, and the value of that will be returned. So basically, what map does is it will accept an operator and collection, and it applies the function on each element of the collection, and it returns another collection based on the return value of the apply function. So I'm just trying to create a custom operator square, and I'm just trying to do a map of square on another list. So as you see, square accepts a number and it just squares it and returns the value. And I'm just applying square on 1, 2, 3, 4, and the value returned is 149616. And the next function is reduce. So what reduce does is reduce operator accepts a reducer function and an optional initial or identity value and a collection followed by that, and it works in the way that I have mentioned here. So it first takes the identity value if it's available, and the first argument of the collection that you have provided, and it applies what are the function that you have provided, and it takes the result of these two this evaluation, and it takes the next value from the collection and the result of the previous evaluation, and it again applies the same function. And so to give an example of what are the demonstration that I have put here, assume that I'm having a function star. So as you can see, it has been evaluated 24, and this is how you will get the 24. So it will take 1 and first element of the collection, apply star, and you will get 2, and it gets the next element of the collection and the previous evaluation result, and it applies star, which is essentially a multiplication, and for whatever the value that you get, it takes the next element of the collection, and it goes on until it digests all the elements in the given collection. So instead of star, you can just create a custom accumulator function. So essentially, I'm just doing the same thing, but I'm just creating my own function, which does the multiplication using the star operator. So I'm almost certain that most of you might have worked in map and reduce in any programming language that you have worked on. So one thing that I would suggest you is to go through map, reduce, and filter. And so almost any operation that we use loops for, you'll be able to do it without loops using recursion, map, reduce, and filter. So do you have any questions so far, or anything to clarify? Are we good until now? Hi, folks. Okay. Cool.
Good, Kannan. Yeah.
Okay. So let's move on to the assignments that we have. So we have certain things to practice and certain things for reference, which you can do it to learn more about some of the underlying concepts which we have gone through so far. So to start with assignments. So you write a function which finds the sum of square of all elements in a vector. So basically, when you have to find a square of all elements, probably you might have to use a map, and when you have to sum it, probably you can use reduce. And you can apply the map and reduce that you have just learned. And read and practice about filter operation. Filter is something which we haven't gone through in the session, but we're just leaving it as part of assignment for you to go through and get a sense of it. And read about the function docstring and add docstring to the function that you have just written. So probably you can use it for the function which is the first one that you have written in the practice one. So what are the functions that we have gone through so far? For the sake of simplicity, we have written it without proper docstring. So docstring is basically a formal command. So it'll be part of a compiled unit for the function. And probably you can try solving a first problem in the project toilet.net. So it's one of the easiest problem which you'll be able to solve using a typical operation that you have seen so far. And to get a conceptual grasp of what we have seen so far, and to get some of the philosophy and some of the backbone of functional programming and things like that, probably you can read more about immutable data structures, and you can read more about what exactly pure function means. And when it comes to functional programming, there is a misconception that if you are from a Java background, so if you are using Lambda or if you're using what are the out-of-box stream operations that Java provides, then you are doing functional programming. Or if you are from other programming languages such as Python or JavaScript, you might be in the sense that if you're using map, reduce, and filter, you're doing functional programming. That's not the case. Functional programming has more to do other than just map, reduce, and filter. So probably one of the primary thing is pure functions. So you can get a grasp of what a pure function means, so which will be useful for you in the upcoming session. And you can also immutable data structure is one of the philosophy of functional programming. So basically, these two things will give you a more conceptual sense of functional programming, and it helps you understand the philosophy and concepts in functional programming, and some of interesting articles related to Lisp and functional programming. So this particular article by Paul Ham explains how he stayed on top of the business compared to his competitor with just 2 programmers using Lisp. So it's an article named "Beating the Averages." So it says basically it'll give you a motivation to learn Lisp, and it's by one of my mentor named Srikumar. So this article is a hypothetical conversation between functional programmer and imperative programmer. If you are new to a functional world, you will be encountering certain questions that functional programming world throws at you. So this article cleanly captures and foresees those things and cleanly captures those things. So it's a nice read. And we have mentioned some links in which you can further read about certain concepts and philosophies behind Clojure. And there are certain sites in which you can use for practice. For example, Purely Functional TV is a newsletter which gives you weekly exercises which you can use for your own practice, and it helps you to keep revising on different concepts of Clojure. And these sites are some of the famous sites in Clojure world to practice Clojure, starting from a beginner to advanced level. So I strongly suggest you spend some time on trying these things out and reading this article that we have mentioned here. So I'm sure you won't regret spending this time on these things. Yeah, so that's what I had to say it on in notes. So you can post your feedback on any improvements that we have to make for this session in meetup section. So we'll also be posting these videos into YouTube. You can also comment there, and you can also comment in our meetup page or in Twitter, either tagging me or Tamil or both. Or you can take time to practice assignments. So that's a very important thing. So as I mentioned a couple of times earlier, Clojure is something which you have never met. So there are certain concepts which you have never met if you're just from imperative programming world. So those things are worth trying. It'll be mind bending and it'll make you feel stupid, but give it a try. It's worth spending the time. And yeah, there is a beginner channel in this particular Slack group, so you can use that to post your question and get answers, and you can discuss. So since it's a beginner channel, so you can feel free to post any question, even if you feel that's stupid. That's fine. And the vision with which we have started this particular group is based on no profit. So it's primarily based to build a good community around Clojure. Since we have seen a lot of goodness in Clojure, we like to build a good community around it. And going forward, we like to see it as an active community in which not just Tamil and me, and we'll also like to see sessions or discussions, or as we started during the beginning of the session, any debates from everyone contributing towards the Clojure Meetup group. We can also try to plan for any hackathon sessions in which we'll take a common goal and we'll sit together as groups and develop things and see whatever that you find useful. So basically, it's not just Tamil and me who will be driving this. It's all of us who will be driving this particular meetup group. That's what the summary. So that's all I have. Tamil, do you have anything to add? Hello. Hello. Am I audible?
Kannan, Tamara is not there, I believe.
Oh, okay. Yeah. That's all I had.
Thanks a lot, Kanan, and everyone who arranged this meetup, and it was really an wonderful session, and I'll surely try some more. I'll surely spend some more time on the closure.
Yeah.
Thank you. Thanks a lot.
Sure. Actually, we'll be planning a follow-up session on additional concepts, so a bit more advanced concepts than whatever we have covered so far. So you'll be able to follow that in effective manner if you take some time to practice the assignments that we have given. So what are the assignments that we have given is thoughtfully chosen to give a sense of what we have covered, and thoughtfully chosen to set it up as state to be ready for the sessions that will be had. So it will be very helpful for you to um, uh, take the assignment seriously and spend some time on doing it.
Yeah. Thanks a lot.